the students of the master degree in aerodynamics, we came to the lab to use the ReMoD apparatus to show them some dynamics of river delta system that we have previously discussed in class. In particular, we were concerned about how this river delta system evolves following autogenic process, meaning processes that are dictated by the river itself without the need for any external fine-tuning. So we came here in the lab and we first ran an experiment for which we can see the final results here, where we reproduce a longitudinal cross-section of a river delta system. So we first look at the dynamics of the system, and then we investigate by manually changing the water level within the flume how river delta system responds to changes in the sea level, which is of course a critical topic of worldwide importance. Then we move on from this 1D experiment, which really represents just a tiny slice of a river delta, to run a 2D version of basically the same experiment. So here again we have a small version of a river delta system. In particular, we have something that simulates the input of water and sediments from a river system, then a basin, which is in effect a small tank filled by water, and the mixture of water and sediment are let to flow freely within the basin to form, as we can see, a river delta system. This experiment right here is actually useful because it can be used despite the small scale that we are using. This experiment can be employed to illustrate the very dynamic through which river delta evolves, which is by lobe switching, so by depositing sediment in a given position of the coastline, and then all of a sudden, over sufficiently long scale, changing the position of the river course and start depositing sediment on another location. This process is iterated through time, generated, as we can see, a very rounded fan-shaped morphology that is in all effect similar to river delta observed over, of course, much larger scale in nature. This type of experiment, despite the small scale at which they run, are very effective, I think, in aiding students to visualize and making a sense of the concept and the tools that we have seen in class during the course.
Good morning, I'm Melissa. I'm a student here in the Earth Dynamics master degree.
And I'm Linda. I'm an Erasmus student here from Sweden.
Today we just experienced a laboratory work with Professor Alvise Finotello about the course of coastal environment under climate change. We took in the class the theoretical part, and it's very important always to visualize what's happening in nature, even in a small scale in the lab. It's very important that we know how the process works, and that's very important that it really stick in mind the idea.
So now we gain a lot of knowledge in class, and we could see it through this experience. So behind us we have these experiments, and it was very nice to visualize what we learned.